Hello everyone, hope you guys are having an excellent day and that you're doing well. So here we have a Gauteng province from, it's a grade 11 maths paper. It's a paper 2 from June 2018. It's 100 marks and it should take you 2 hours or no more than 2 hours. If you want to download the paper, just click the link below the video. Then you can see what questions are in the paper and you can fast forward to any specific part that you would like to go over. All the best, lots of love, smash this paper, guys. Here are all the questions that we'll cover for this one, but I will split these up onto individual pages just so it's easier for us to work with. But maybe you want to try all the questions yourself first, I'm not sure. But let's begin. So here's the first set of questions. So they tell us that in the sketch below, the coordinates of the vertices of A, B, and C. Okay, so they give us A, B, and C. Point F, this part's very important. This line over here. Point F is a point on AC such that AF is equal to CF. Now, I like this question. You know why? Because we can clearly see that F doesn't look like it's in the middle of this line. But remember, diagrams are not necessarily drawn to scale, and so here is a clear example of that. So we need to remember, even though it doesn't look like it, AF is going to have the same length as CF, okay? Because that's what they tell us over there. That's important that you understand that. Even though it doesn't look like it, they've told us that it is. They carry on to say that line BF and, okay, so BF and BC make angles of theta and alpha respectively. Okay, so yeah, we can see that this line makes an angle theta and this line makes an angle alpha. Okay, with the axes as indicated. Okay, excellent. So everything they said here we have seen on the diagram. First question for 2 marks. Calculate the gradient of BC. Alright, so we know the gradient is y2 take away y1 over x2 take away x1. Now I'm just going to use the coordinates of B and the coordinates of C. I'm going to call this point number 2. I'll let this be point number 1. So the formula says that we need to use the y value of point number 2. And so the y value of point number 2 is over there, so it's a 3. Then we subtract the y value of point number 1, which is a 5. Then we have the x value of point number 2, which is a 5. And then we have the x value of point number 1, which is a 7. And if you had to go work this out, it's negative 2 over negative 2. Then for the y value of point number 2, and then for the y value of point number, well, let's first put a minus there. For the y value of point number 1, it's a negative 5. And then for the x value of point number 2, it is a 5. And then for the x value of point number 1, it is a 7. Go ahead, and then if you had to work this out, at the top it'll be 8. At the bottom it'll be negative 2. Simplify that, and it is negative 4. The next question says, calculate the coordinates of F. Okay, so remember, F is the midpoint of AC, because they said that this length is the same as that length. So we can use the midpoint formula then, which is going to be x1 plus x2 over 2, y1 plus y2 over 2. And so I'm going to let this be point number 1, this be point number 2. You can do it the other way around. It really doesn't matter. I'm just helping you to see what I'm doing. And so the x value of point number 1 is minus 1. The x value of point number 2 is 7. Okay, and then the y value of point number 1 is 1. The y value of point number 2 is negative 5. Now you see this is a positive and a negative, so we can just change that to a negative over 2. So this becomes 6 over 2, which is 3, and this one becomes negative 4 over 2, which is negative 2. And so F's coordinates would be 3 and negative 2. The next question says that determine the equation of median BF. Okay, so let me explain what a median is. We don't really need to know what it is right now because we know the coordinates of both, so we can just get the equation. But sometimes they won't ask this question first. So you would be left with just that. And you would need to know what a median means. So what is a median? Well, let me explain. A median is the following. You take any point in the triangle, okay? So let's say we choose this point, and you go to the opposite side, which is this one, and you go exactly to the midpoint of the opposite side, and then you connect those two. That is what a median is. So it goes from one of the triangle vertices, or one of the corners, to the opposite side, and it must cut the opposite side exactly at the midpoint. Let me show you a different part. So I don't know why that did that. Let's say we chose this part here. Then you would look at the opposite side, which is this one. You would look at the halfway point, and that would be called a median. Whoops, it didn't really connect perfectly there, but there we go. Okay, so that's what a median does. So if they didn't ask you question 1.2, then you wouldn't know what these coordinates were, but you would understand that a median is this line over here. So you would first go calculate the midpoint, but that's what they asked us to do in the previous question. Okay, but sometimes they'll leave that question out to make it a little bit more challenging for you. So we have to find the equation. We know that it's a straight line, so y is equal to mx plus c. First step, let's go find the gradient. So that's the formula y2, take away y1 over x2, take away x1. I'll call this point 2, I'll call this point 1. You can reverse that, it doesn't matter. So the y value of point number 2 is 3. The y value of point number 1 is negative 2. Two negatives over here. I'm going to make that into a positive. The next one is the x value of point number 2 and the x value of point number 1, which is 3. Go ahead, and that would be 5 at the top, 2 at the bottom. So you could write it like that, or you could write it as 2.5, but I'm going to leave it as 5 over 2. So we can then say that y is equal to 5 over 2x plus c. Remember that these questions are going to carry on onto the next slide. There's quite a lot of questions coming up. So to find c, you need to substitute any point on that line. So you could choose this one or this one. I'm going to go for, it doesn't really matter, you get the same answer, but I'm going to go for this one, just to avoid those negatives. So, y is going to be 3, x is 5, plus c. Now, we're just going to say 3 is equal to, now this, if you type it in the calculator, is going to be 25 over 2 plus c. Take this 25 over 2 to the left. So you end up with that. And so c would end up being negative 19 over 2. So the final answer for that question will be y is equal to 5 over 2x take away 19 over 2. This question says, calculate the size for 5 marks of angle FBC. And they also only want one decimal place. So, or one decimal figure. Or I guess that, yeah, one decimal, it's the same thing. I just thought it sounded funny, but it's one decimal figure. Some people do say it like that. Okay, so calculate the size of FBC. So angle FBC. So if we go there, there, there. All right, now listen carefully. I've seen these questions many, many times. You're just going to work with a triangle. And no, I'm not talking about that triangle. That's not a good triangle. A good triangle in these questions is the one that also uses a horizontal line. There we go. Okay, it must have a horizontal line. It just makes it so much better because then we can start to use inclination angles, because inclination angles are angles that are relative to the horizontal lines. The horizontal line doesn't always have to be the x-axis. BT dubs, by the way. So, for example, sometimes it's not this question, but there are certain questions where it makes, where the way that they set it up, there is no ability to use the x-axis very nicely, and so then you would use like a horizontal line like that. So it's not always going to be the x-axis that you're going to use as a horizontal line, but as long as it can be a horizontal line, because then, as I said, we can use the inclination angles. So, when we're busy with inclination angles, I want you to remember the three things that we must remember is that inclination angle is always in conjunction, or always in, we always use it together with tan and the gradient. Okay, so there's like a link between all of that. Tan gradient, inclination angle. They are a family that you must never forget about. Tan, gradient, inclination angle. Okay, they go together. So what do you mean, Kevin? What are you talking about, bro? This is starting to feel a little bit weird. So what I mean is that if you know the sin, cos, and tan. So if you also know the gradient of a line, you can work out the angle. Or if you know the angle, you can then use tan to work out the gradient. So they're just one big family, okay? It doesn't matter what your triangle looks like. I'm not trying to say like some type of like distance, speed, and time formula here. What I mean is like just keep them together. They are one family or one group of things that go together and they work very well together. So the way that we can do this is check this out. If we know that we can work out the gradient of that line. In fact, we actually know the gradient of that line. It was 5 over 2. I'm not going to write 5 over 2 like that. Chigga's guy be writing with his highlighter. So 5 over 2, guys, I don't know. I get the most random little things that pop into my head. So 5 over 2 was the gradient of that line. So if we know, and you might be saying, yeah, but Kevin, that's the gradient of FB, my brother. We need the gradient of this, we need this angle. But remember, this is all one line, homie. So we can work out the gradient of that line. So we can say that the gradient of the line BF is 5 over 2. So we can work out the angle by using tan. So we can say, because let me show you how it works. We know that if you have tan of the angle, then it equals the gradient. Okay, so tan of theta is equal to the gradient, which is 5 over 2. But now to get theta, we got to use the reverse of tan, which is going to be called inverse tan. And that's where you use the whole, what it means is that theta is then going to be equal to the inverse of tan, 5 over 2, which is where you use shift on your calculator. So you're going to say shift tan of 5 over 2. And to round that off to 2 decimal places, that's going to be 68. I know we said 1 decimal, but we can do that at the end. So we say 68.20. Now, what is that? That is called the inclination angle. And it is the inclination means inclination above any horizontal line. So it doesn't only mean theta. It also means if we had a horizontal line, you could also have said that that angle is 68.2. Okay, so it's any horizontal line. So that means theta is going to be 68.20. So we have that now. Now what you do is you go work out alpha. Now with alpha, things are going to get a little bit more interesting. You'll see why now. So we already know the gradient of BC from a previous question is -4, okay? Now, when there is a negative gradient, you are going to ignore this negative. You're then going to go work out the shift tan of +4, and that's going to give you 75.96, but that is not the inclination angle. To then get the inclination angle, that was never going to work out as inclination, you are then going to say 180 minus that number. This is just something you need to remember whenever the gradient, is negative. You don't put the negative into the calculator, you get this number, and then you just say 180 minus that, and this will be your inclination angle, which is 104.04. And remember, your inclination angle is always the angle that is on the right-hand side. So that would be alpha. So that would be 104.04. So we can say alpha is 104.04. So please remember that when you have a positive gradient, then you don't need to use the 180 minus technique, and you don't have to worry about any negatives or anything like that. When you have a negative gradient, then I want you to ignore the negative in the gradient, get the angle, and then just say 180 minus that angle. Okay, and then remember, inclination angle is always the angle that is on the right-hand side. Good stuff. Now remember, our original goal is to find this angle up here, but now things become really easy, because here you've got a triangle, and you've got this angle on the outside, you've got this angle on the inside. You would definitely know how to eventually get this angle. However, there are different ways that learners try to do. Some learners, they would work on, over here, they would go angles on a straight line to work out this angle, and then they would use sum of angles in a triangle to get this angle. But some other learners use exterior angle of a triangle, and that is faster. But I know that when I was in grade 11 and 12, I wasn't comfortable with that. But these days, I'm comfortable with it. And I know a lot of learners like to use this method, so I'll use it. It's a little bit faster. So what we have is we know that this is 104.04. But by the way, those of you that don't like to use exterior angle of a triangle, then just use angles on a straight line. Find this angle. You already have this angle. And then you could easily find this one. Okay, but for those of you that are using exterior angle, we know that the exterior angle of a triangle must always be equal to the sum of the two opposite angles, those two. So we could then say that 104.04 is equal to 68.20 plus angle FBC. And the reason for this is exterior angle of triangle. Then if you simply had to go and solve for angle FBC, we will get 35.84 degrees. Oh, but they wanted us to round to one decimal place, so 35.8. So 35.8 degrees. If the coordinates of K, where's point K? Okay, so K is just a random place. I even looked in the question description, which we had in the very beginning. I just went back a few places, check to here, for example. There's no mention of K. All right, so K is just some random points, 6 and P. So its X value is 6, okay, but its Y value is P. Now, we don't know if that's above or below, but I think the next piece of information might give us a guide. Calculate the value of P if the angle AFK, okay, so from A to F to K is 90 degrees. Oh, AFK is 90 degrees. Okay, so that would look, I guess, I mean, that's almost 90 degrees, but let's not use it as that. So we could maybe like go something like this. Okay, so we make it a 90 degree. It's a bit weird because F's actually over here in real life. But yeah, I don't want to cause any confusion. So let's just say it's like something like this, okay? And now we know that the X value is 6. So this X value is 5, this X value is 7. So it's somewhere in between. So it's probably like there. Okay, so it's probably there. So this part's not that important, but let's just go say 6 and P. Alrighty, so let's go work this all out. So what they tell us is that this angle, AF to FK, is 90 degrees. So what I would immediately do is I would just know that when two lines are perpendicular, or when two lines make 90 degrees, there is this property that says that when you multiply their gradients, you end up with -1. So what I would do is go work out the gradient of AF so long. This one over here. So we're going to use y2 take away y1 over x2 take away x1. And so I'm going to use this as point number 2. This is point number 1. And so that would be -2 take away 1 over 3 take away -1. And that's going to end up giving us -3 over 4. Okay, so we have the gradient of AF. Now we can just go plug that into here, for example. So you could say -3 over 4 multiplied by the gradient of FK, which is this line. And that should give us -1. So then the gradient of FK could be -1 divided by -3 over 4. And if you do that correctly on the calculator, you should end up with 4 over 3. So the gradient of FK is going to be 4 over 3. So now that we have the gradient of FK, we can now just use the gradient formula in reverse. So we know that gradient is y2 take away y1 over x2 take away x1. And so we can say that 4 over 3 is the answer, or that is the gradient. And then we can use, this could be point number 2, and this could be point number 1. So let's just cross all that out. So then you could say y2, which is going to be p, take away y1, which is -2, you see over there, over x2, which is 6, take away x1, which is 3. Now let's just go simplify a little bit. This becomes p plus 2 over 3. All right, so now you could realize, check this out. These are both 3s, so you can just ignore them, because if you have an equation where the denominators are the same, you can ignore that. And now you can just solve for p by saying 4 take away 2, which is 2. This question says, calculate the coordinates of point T, given that ABCT is a parallelogram. Now, it is so important that this order is followed. They said A, B, C, T. So check this out. A, B, C. Now, whoa, what happened there? Drunk driving. So if you have a parallelogram, then T would have to be somewhere there, for example, to make it a parallelogram. But if, for example, they said BACT, let's say they said BACT, then you would start at B, you would go to A, C would then be next, and then T would have to be up here. You see, so the order does matter, okay? So follow what they've said. So A goes to B goes to C, and then C goes to T, which would be somewhere here. Okay, now, how do you do this? It's super, super easy because it's only 2 marks. You're going to use the process of inspection. So just look at B and look at A. How did they go from B to A? Look at the x values. It went from 5 to -1. So how did they do that? They went 6 left. Do you agree with me? They went from 5 to -1. That means 6 left. And then look at the y values. They went 3 to 1. See that? So that means they went 2 down. So 6 left and 2 down. So you can do that exactly the same way. From C to T, you're going to go 6 left and 2 down. So if you go from 7 and -5, which is C, and if you go 6 left, that's going to become 1, right? If you go 6 to the left, that becomes a 1. And then this, if you go 2 down, becomes -7. And so the coordinates of T you can say is 1 and -7, and your reason can just be inspection. This question says, prove that the diagonals of this quadrilateral ABCT bisect each other. What does that even mean? So if you have a parallelogram and you have diagonals, then this point is going to be the same for both diagonals. So what you're going to do is you're going to first find the midpoint of this line, and then you're going to find the midpoint of this line over here. And what you would find is that they are both going to be at exactly the same place. That is all that you're going to do, okay? Because then that means that this line is cut in half, so that those two would be the same, and then these two would be the same. That is what bisect means. So we are just simply going to have to go and work out, so pretend that there was a diagonal there, boom, and then there's a diagonal there, boom. So we're going to go work out the midpoint of AC. Let's go work out the midpoint. So midpoint is capital M of AC. Now we know the formula for midpoint is x1 plus x2 over 2, and then y1 plus y2 over 2. And so I'll call this point 1, I'll call this point 2. Whoopsie, can't see there. And so that's going to be -1 plus 7 over 2, and then 1 plus -5 over 2. And then if you had to work that out, you're going to end up with 3 over here and -2 here. So that's going to be 3 and -2. Now let's go work out the midpoint of TB. And so I'll call this point number 2, this point number 1. It doesn't matter. I'm just trying to help you guys to see what I'm doing. And so that's going to be 1 plus 5 over 2, and then -7 plus 3 over 2. If you had to go work out each of those individually, you should get 3 and -2. So you see what happens there? The midpoints are the same. And then from that, you can literally just say, therefore, the diagonals of quadrilateral, you can say quad if you're cool, bisect. That's it. This question says, determine the perimeter of a new parallelogram, LMNO, which is an enlargement by a scale factor of 2. So what does that mean? It means that there's this other parallelogram, LMNO, which is going to be double the size of this one. So all that we're going to go do is we're going to work out the length of this line over here, for example, and that'll be the same as the length of this one. So that one and that one will be the same. So you don't have to go work out the length of both. That's just a waste of time. And then we're going to go work out the length of this line, and that'll be the same as the length of this line. So what that would allow us to do is to have the perimeter of this, that'll give you the perimeter of this parallelogram. Then we'll just take that answer and multiply it by 2 because because the LMNO parallelogram is a factor of 2 larger. That's it. Okay, so let's go work out the length of AB. So we're going to use the distance formula. Okay, and so I'll use this as 0.1 and I'll use this as 0.2. And so let's just have a look. That's going to be 5 take away -1. And then 3 take away 1. If we go ahead, just go type that all in on the calculator exactly like that. You end up with, leave it in a square root form for now, 2 square root 10. And then, okay, so that would be the length of AB. So AB and CT are going to be the same length, 2 square root 10. Okay, now we're going to go look at because that's the opposite sides of a parallelogram. Now let's go look at the length of, so now we're going to go get, for example, the length of BC. So that would be, I'll call this 0.1 and I'll call this 0.2. So that'll be 7 take away 5 plus -5 take away 3. And if we go work that out on our calculators, that'll give us 2 square root 17. Okay, so now we can get the perimeter of ABCT, because we know that that's just going to be this length multiplied by 2, because there's 2 of those. There's this one over here and there's this one over here. Then we're going to say plus, and then we're going to say 2 square root 17 multiplied by 2 because there's 2 of these. Okay, and then if you had to go work that all out, you end up with 4 square root 17 plus 4 square root 10. We're then going to multiply that by 2 to get LMNO. So parallelogram LMNO would be 4 square root 17 plus 4 square root 10. Whatever that is, remember to put in brackets if you're writing it again, and then multiply that by 2. And then to 2 decimal places, we should be getting 58.28. And then we could just say units. In the figure below, the coordinates of P are given with that angle is equal to alpha and the length of OP is 5. Okay, so that length over there is 5. The first question says, determine the value of K. Well, what you need to understand is that this little point over here, we can do the following. Imagine this line didn't exist. Okay, and there was no 5 over there. Then think about this. This length over here, this vertical length would be 3, because that is a y value of 3. And then this length over here, so for example, if this was, let's say this is -2, then you would say that this length is -2. So we could put k over here, okay? So k is over there. And now I'm going to put everything back. So now we know that this is 5. So now we can go and use Pythagoras, and we could say 5 squared is equal to 3 squared plus k squared. And so that would be 25 is equal to 9 plus k squared. And so that means that 16 is equal to k squared. And so k, if you take the square root, we always say plus and minus 4. But now k cannot be a positive value, because we know that here this k is a negative value because it's a negative x value. So we will say that k is -4. This question is asking us for tan alpha. Now remember, when they say this is the angle, you just forget about that and just pretend that it's over here. Now we're going to go use tan. So tan is always equal to, if we think about SOHCAHTOA, tan is opposite over adjacent. Some learners would prefer to use y over x. And so whichever method you prefer, you should eventually end up with tan alpha is equal to 3. Oh, we should probably go fill in k here. over -4. Now, some learners, they want to then carry on and they want to like use shift and all of that stuff. But remember, if you go and use shift now, then what you are determining is the angle alpha. But they didn't ask you for the angle alpha. That's only in this question. Here they are literally just asking you for tan alpha. So you leave it there. That's the answer. So it was -3, or just to say 3 over -4. Okay. Now, when you get something like this, just think of your 4 co-functions. So we know that sin of 90 minus alpha is cos. Cos 90 minus alpha is sin. Sin of 90 plus alpha is cos. And then cos of 90 plus alpha is negative sin. Okay, so then we can say that cos of 90 plus alpha is the same as negative sin alpha. And then we can just go work out what sin alpha is, because that's this triangle. And so remember, sin is opposite over hypotenuse, or some learners prefer to use the y over r method. And so whatever you choose, it's going to end up being negative, and then sin is going to be 3 over 5. So the answer will be -3 over 5. Now here they are asking for alpha, so we can just come back to this, and we can say that tan alpha is 3 over -4. Now you're just going to use reference angles and all of that from general solution. So with general solution, remember, we don't put the negative on the calculator. Only some schools in South Africa use the negative on the calculator, but most of the schools, like 99%, don't. Okay, so you're going to just find your reference angle by saying shift tan of positive 3 over 4. And if you work that out, I'm going to keep 3 decimals for now. So that's going to be 36 point, I'm just going to write down the first 3 decimals, 869. Then we got to understand that tan is negative in quadrant number 2 and quadrant number 4. But remember, with tan, we are in quadrant 2, so we're not going to go work in quadrant 4, because that's going to end up giving you a large value, like 323 or something like that. So we're going to work in quadrant number 2, okay? And so that means that we're going to say 180 minus 36.869, and that'll be 143.13 degrees. Here it says that given that A and B are complementary means that A plus B, they will add up to 90 degrees. If it was supplementary, then it would be 180. Here they say that 7 cos A minus 3 is 0. Then it says determine 7 cos B minus 3 tan A. Okay, so what we do, we take this expression over here. Let's go work out what cos A would be. So we say 7 cos A minus 3 is 0. Get 7 cos A alone by taking the 3 over. Then divide everything by 7. All right, then make yourself a triangle. Put this angle as A. This is 90. Now, if A plus B is equal to, if A plus B equal 90, then this is B. Let me explain. If this is 90 degrees, and all of the angles in a triangle add up to 180, then it means that these two must add up to 90, so that you have 90 over there and then 90 over there, which is 180. So these two must be 90, and that's what we said. Okay? So there we have our triangle. Now, remember from SOHCAHTOA, we know that cos is adjacent over hypotenuse. But here they're saying cos A. So we go to angle A. So that means this is the adjacent side, this is the hypotenuse, and this is the opposite. So we're going to say cos of A is 3 over 7. So that means this is 3 and this is 7. We could then use Pythagoras to find this missing side. So we could say 7 squared minus 3 squared, which is 40. We then take the square root of 40, which is 2 square root 10. So we can say 2 square root 10 over here. Now we can take this part over here, which says 7 cos B. Okay, so we can go, and then 3 tan A. So let's go work out cos B. So cos B. So now we are looking at this angle here. So that means that this is the adjacent, and this is still the hypotenuse. Okay, so that's cos B. Then we can go work out tan A. We know that tan is opposite over adjacent, but remember, you're starting at angle A. So what is the opposite of angle A? It's 2 square root 10. And then what is the adjacent of that? 3. And so then we can go full in this expression over here, which is then 7 cos B. Sorry, 7. Now, cos B, what is cos B? Cos B is that. So we can say is that minus tan of A, which is that over there. Now remember, these two are going to cancel, and these two are going to cancel. And so that's going to be 2 square root 10, take away 2 square root 10 to get a final answer of 0. This question asks us to simplify without the use of a calculator. So we definitely need our cast diagram. We know that this is the 180 minus theta, 180 plus theta, and 360 minus theta. We know that sin is this quadrant, or sin is positive in that quadrant, tan is positive here, and cos is positive over here. Any angle that is so this goes from 0 degrees all the way around to 360. Okay, so that's 0 up to 360. Any angle that is not one of those, or between 0 and 360, you need to modify it. How do you modify it? Well, let's go through that. So 210, that's fine. 790, that is not okay. So what you do is you are allowed to either add 360 or minus 360. So we'll minus 360, which is 430, but that is still too big. So we minus another 360. And so that then becomes 70. This angle here is too small. You see it's negative. So what you do at that angle is you add 360. Okay, so let's go write that down. Sin of 210 times by cos of 790 minus 720, because I said minus 360 twice, and that's 720. This one is minus 330 plus 360 over the sin of 160. So that becomes sin of 210, cos of 70, tan of 30 over sin 160. Okay, now everything is between 0 and 360. That is brilliant. Now we need to go and reduce any number that is bigger than 90. So any number that is bigger than 90, such as this one and this one, needs to be reduced. Okay, so the way that you'll do that is 210 is over here. So we'll say that that is the same as 180 plus 30, because that's still 210, right? And then cos 70, we leave it alone. Tan 30, we leave it alone. Sin of 160 is going to be 180 minus 20 degrees. So that's here, because that still gives you 160. Now, as soon as you have it like this, you can change this part now to sin of 30, this part. But sin is negative in that quadrant, so you put a negative in the front. Here you say cos 70. Here you say tan 30. Here you're going to say sin 20, and sin is positive in that quadrant, so you leave it like that. Okay, now, whenever you have something like this happening where this one is and this one, and they add up to 90 degrees, I want you to think about cofunctions. Sin and cos have this relationship, so you can test this on your calculator. If you have sin 10 on your calculator, and then you type in cos 80, they will give you the same answer. Look at this, they add up to 90. One of them must be cos, one of them must be sin. Maybe we have sin of 30, and the other one is cos of 60. If you go type them on the calculator, they are exactly the same thing. So what we do is we choose one of them, either the bottom or the top, it doesn't matter, and you change that one. So I'm going to change this one to sin 20. Let me show you that again. I changed cos 70, and I changed it to sin 20. The reason I did that is because now these two can cancel. And so now we are simply left with negative sin 30 multiplied by tan 30. Now those are special angles. So with your special angles, now I'll be honest, back in the day when I first started teaching, you really had to use your special angles, but now when I look at memos these days, they're not even using the special angles, they're just using the calculator. So you must just check what your teachers are doing, but sin 30, if you type that on the calculator, that's a half. If you type in tan 30, on your calculator, it is square root 3 over 3, and that's what they have on the memo. However, if you actually used the real special triangles, that would have given you 1 over square root 3. These two are actually the same thing, believe it or not. But yeah, so it looks like I've been noticing this over the last few years that they don't even use the special triangles anymore. So just check what your teachers are doing. So if you had to now go multiply all of this together, you should end up with a negative square root 3 over 6. Here we have a proof, so I'm going to work on the left-hand side. Okay, so the first thing I would do at the top is I would just take out a common factor. That common factor would be sin x, and then you would be left with 1 minus cos x. At the bottom, I see there's this sin squared x. So we know from our formula that cos squared x plus sin squared x is always equal to 1. So if you had to get sin squared x by itself, there's many ways you could handle this. You could even somehow use this little 1 over here, but it's not necessary. I would get sin squared x by itself, and that's going to be 1 minus cos squared x, and I would go and replace that part with that part over there. And some wonderful things are going to happen. Let's have a look. Cos x minus 1 plus 1 minus cos squared x. The wonderful things I was talking about was that this minus and this plus 1 would cancel. And so we're now left with that over there. Now at the bottom, take out a cos as a common factor, and you're left with 1 minus cos x. Top and bottom cancel. And so you're now left with sin over cos, which is equal to tan. And therefore, the left-hand side is the same as the right-hand side. Here we have it's almost like a general solution kind of question, but they've given us an interval to work with. So this is actually a specific solution question. But for now, you can actually ignore that completely, and so you're going to ignore that and then go do the general solution like you normally would. You know, where you have the plus k 360, all of that stuff. Let's go do that. We'll only look at this at the end. Okay, so let's see here. So if you've watched my videos on trigonometry general solutions, you would know that there are different categories of questions. Now, sometimes when you have a sin and a cos, we might be tempted to think about tan. However, look at this angle and then look at this angle. They are completely different. So we cannot use the tan method. This is where we are going to rather use a co-function method. Okay, if you've looked at my general solution questions for grade 11, it's the last type that I've taught or that I've showed. It's the type where we use co-function. So the way that one works is I typically suggest that learners just leave this one alone. You could change this one, but I just like to keep things constant. So I leave this one alone. You then change this one to sin 90 minus, okay? And then whatever's here, you put in a bracket. Close the bracket, and then close this bracket. Okay, that's step 1. So now what we do is we see we have sin on both sides. Now, you've probably done questions like that before, where I have showed this, where if you have sin on both sides, you can just cancel it. And so you end up with 2 theta equals to 90 minus theta minus 30. I just multiplied that negative into the brackets. Right, this is the part where you've probably heard me say, stop. Okay, stop. Because what learners now want to go do is they just want to carry on and solve. But what you've got to realize is that this part here, you can simplify this, of course. It just becomes 60. That's okay. This, on the right side, is your reference angle. Okay, so you know how you would normally have like sin theta equals to 0.4? What would you do here if you were solving this? Well, you would first say shift sin 0.4, and that would be, this is just an example. That would give us 23.58. You would then go work in the quadrants where sin is positive, okay? And so that would be quadrant 1 and quadrant 2. And so you would say theta equals, because it says theta over here. But now we don't have theta, we have 2 theta, okay? So we are going to go work in the quadrants of sin, where sin is positive, because here we have sin and here we have sin, and there was no negative in the front. So the quadrants of sin being positive is quadrant 1 and quadrant 2. So in quadrant 1, you're just going to say 2 theta is equal to your reference angle, and then plus k 360. K is an element of z. In the second quadrant, you always start with 180 minus. Then what do you minus? Your reference angle, right? There we go. Go ahead and now simplify. So we can take this theta over, which becomes 3 theta. And so you end up with theta equals to 20 plus k times 120. K is an element of z. And then with this part over here, you're going to say 2 theta is equal to 180. Now put the minus in, so minus 60 plus theta. And so that's going to give us, bring this theta over to the other side. So that'll be theta equals to 120 plus k times 360. K is an element of z. Okay, so we have our 2 general solutions, but we don't have our specific solutions. Okay. So let's go write everything down. So we have theta equals to 20 plus k times 120. K is an element of z. Then the other answer was theta equals 120 plus k 360. K is an element of z. What we do now, okay, let's start, let's actually clear up some space. We're going to start with one at a time, okay? So let's do this first one over here. And you're just going to go choose numbers for k. But only integers, that's what this part means. Any number like 0, 1, 2, -1, -2. So I'm going to start with k equals to 0. So let's see what happens. Theta equals to 20 plus 0 times 120. That'll be 20. Is that inside here? Yes, it is. So there's my first answer. So I can open up this funny bracket. Ooh, I actually got that one perfect. Ugh, not too bad. 20. Okay, now I just go let k equal to 1. So we go change k equal to 1. And what does that give me? 140. Is that inside here? No, it's not. Okay, so that's going a little bit too big now. So then I change k equal to -1. Let's change it to -1. So, okay. And that would be 20 minus 120, which is -100. Yep, that fits. Excellent. Then I change k equal to -2. What is that? Ooh, -2, Kev. So that'll be 20 minus 240. And that's -220. Then let's try k equals to -3. That will be -340. That also works. Lovely stuff. Okay, now if we had to go k equals to -4, it'll go too big, or it'll be too small for this. So I'm not going to go there. Now we move on to this next one. So we start with k equals to 0. So k equals to 0. And so that'll be theta equals to 120 plus 0, and that'll be 120. That is too big, so we don't do that one. Then we go to k equals to 1. So let's actually just replace it over there. Oh no, that would be too big. My bad. If it's already too big at 0, then we wouldn't go up to 1. So let's rather go to -1. So that'll be -1. And if you work that out, -240. All right. Then let's let k equal to -2. I think it's going to be way too small. Yeah, -600. So these are our only answers over here. This question says that the functions of cos 2x and sin x plus 45 are given. Use the answer sheet, which is this one over here, to sketch the graphs. Okay, 6 marks, guys, and it's going between -90 and 180. Now, this is easy marks. Why? Because we're going to do it on the calculator. Let me show you. Step 1, put your calculator into table mode. So you say mode, and then you look for table. Now, I've got the silver calculator, but maybe you have a pink, blue, or black one, and so it might be a different number, but you're looking for table, and there we go, f of x. So let's go write out the equation of f of x, which is cos. So we're going to say cos 2. Now, it says cos 2x. So how do you get an x? Well, can you see that on your calculator, look at one of those brackets. I think it's the right-hand side bracket. There is an x there, but it's in red. So you push the red alpha button. So push alpha and then push that bracket. And that'll be cos 2x. Press equals. g of x, this is your other equation. So that's going to be sin, so you push sin, alpha, the right bracket again, plus 45, close the bracket, press equals. The starting position is the starting position that they have given us. Can you see in the x is an element, there is minus 90. That is your starting position. Okay. Press equals. Your ending position is what they've given us, which is 180. Press equals. Now, step we need to talk about. For the step, I'll bring the calculator back soon, but for the step, this is so important. It is going to be the period of your graph divided by 4. Now, a normal graph like this, a sin graph, has a period of 360, because this x plus 45, that just moves the graph left and right. It doesn't change the period. What I mean by that is the following. A sin graph goes to 360. A cos graph also does that. If you move the graph a little bit left, then it's just going to look like that. But this distance from one, or let me do that properly, sorry. That distance from start to finish is still going to be 360. Okay, but this graph here, okay, so first of all, a normal cos graph is 360. That distance is 360 degrees. However, if you change this number, if you make that a 2, it actually makes the graph shorter. It halves the graph, so it goes, so where this graph end, yes, it would end over there. So it's going to make it a little bit shorter, and it's going to end over there at exactly halfway. So how long does the green graph take to complete? Well, it'll only be 180. If you ever want to work out the period of a graph that has a number there, all you do is you just use this formula. You just say period equals to 360. And that is the normal cos and sin period, and then divide it by this number, and that'll give you 180. So now we have a little bit of a weird scenario. We've got two graphs that we're going to draw. One of them has a period of 360, which is the sin graph, and one of them has a period of 180. Well, you are going to have to take the smaller period and use that one for this whole thing. So for your step, you are going to say 180, not 360. You're going to use the smallest period, and you're going to divide that by 4, and that is going to be 45 degrees. So let's go back to the calculator, and we are going to change the step to 45 equals. And now it populates, that's a nice word, Kevin, it populates all of the values that you are going to need for your calculator. So it's got all the x values, you see them, going all the way between minus 90. Let me explain. See how it starts at minus 90, then it goes to minus 45, and then it goes to 0, then to 45. So you see how it's stepping by 45? That's what we told the calculator. And it's going to go up to 180. Why doesn't it go past 180? Because we told it that we wanted to go. We said the starting position is minus 90 and the ending position is 180. Now, for the y values, we've got the y values for the first graph, which is f, and so we've got all of its y values, okay? And then we've got all of the y values for the graph of g, and there they are. And so now we literally just need to go plot all of those points. And so there are all of the values that we are going to use. Okay, so we need to just think about how we want to label all of this. So, okay, so we only, on the negative side, we're only going to have negative 90 and negative 45. So I think what I'm going to do is I'm going to let every 3 lines be 45. So that'll be 45, 90, 135, and 180. That works perfectly. Minus 45 and minus 90. Okay, so let's quickly just go put that in nicely there. 45, 90, 135, 180, negative 45, negative 90. Okay, and then the y values are going to go all the way between, I think the largest one is 1 and the smallest one is negative 1. So I think I'm going to let 1 be up here, and then minus 1, 1, 2, 3, 4, 5 would be there. 1, 2, yeah. And then this would be 0.2, 0.4. So we didn't really have to write that down, but 0.2, 0.4, 0.6, 0.8. So we space it out as much as we can. You don't want to draw like little graphs here and like that. Like, come on, bro. It's got to be more expanded, you know what I mean? So we can actually see how it goes. Okay, so minus 1. So let's go plot. So now we can go plot. So I'm gonna start with this x value of minus 90, and the graph of f has a y value of -1. So that's gonna be over there. Okay. Then I'm gonna plot this point. So the x value is -45 and the y value is 0. So that's that point. Then it's the x value of 0 and a y value of 1. So this is just the first graph. This is f. So that's over there. And then 45 and 0, which is there, 90 and -1, 135 and 0, 180 and 1. And now we can connect. And so that is the graph of f. Now, for the next graph, which is g, so we're going to start with an x value of -90 and a y value of -0.7. So let's go to our x value of -90. Okay, now you see this is 0.2, 0.4, 0.6, 0.8, or negative. So 0.7 would be somewhere in between. So that would be over there. Okay, and then the next point is -45 and 0. So that's over there. 0 and 0.707. So that would be over here. And then 45 and 1, so 45 and 1, 90 and 0.707, which would be over there, and then 135 and 0, there we go, and then lastly 180 and -0.7, which would be over there. And so that is the graph of G. See, I just took the arrows away. I'm not sure if you saw that there were arrows there, but we don't actually want to show arrows because they've given us a clear ending and, the ending positions. Okay, so there we've drawn it, but now they say, please indicate all turning points. Okay, so let's go do that. So this one, the coordinates here would be 0 for x and 1 for y. Here we have a turning point where x is 45 and y is 1. Here we have a turning point, x is 90 and y is -1. And then this is actually a turning point over here as well, because if you think about it, this graph's going like that, and then it would actually be turning. So that's -90 and -1. So there's the turning points. Then they said the intercepts that the graphs make with the axes. Okay, so that would be this point over here, which was x0, y 0.71. I'm just going to round that to 2 decimal places. This here is another one, so that's x is -45, y as 0. Here we have x as 45, y as 0. Here we have x as 135, y as 0. And so there we've done all the intercepts with the axes. Okay, so here they want us to find the range of f. Now f is the red graph. Okay, so the lowest y value is -1 and the highest y value is +1. So you always do the lowest y value first. So we could say y is an element from -1 up to +1. I'll show you how to use set builder soon, or like in a few seconds. So that's both of these are included because the graph touches those points. Now, this next part is we say y will be bigger than -1 and smaller than equal to 1. That's if you prefer set builder. So for this question, it says that we need to find the period of G. Now, G was this graph, which was the sin graph, which is sin of x plus 45. And what we said was that this graph is a normal sin graph that has moved 45 degrees left. So if you take a graph, a normal sin graph, which has a period of 360, and you move it a little bit to the left, it's still going to have the same period. The period is the distance to make one complete cycle. So the period will still be 360, which is what a normal sin graph is. This last one says that what is the number of x values where these two graphs are equal? The two graphs are equal wherever they cross over. So they cross over there, they cross over there, and they cross over there. So that is 3 times. So we can just say here 3, or we can actually just say 3. This question, for only 2 marks, says determine the values of x, but now it only says between 0 and 180. So that means we're not looking at any of this over here, okay? So we're only going between 0 and 180, and they want to know where will this graph multiplied by this graph be smaller than or equal to 0. So if you've watched my videos on how to do these questions, what you'll remember is the following. And so for these types of questions, we need to make a table, okay? So the way that the table works is, well, we have these different scenarios. So, okay, I'm not going to have enough space. So if you have a cos 2x graph, and then you have the sin x plus 45 graph, okay? And then you also need to write out what happens if you multiply them. So cos 2x multiplied by sin of x plus 45. So you could have different scenarios. Cos could be positive, and sin could be positive as well. I'll explain what all of that means shortly. You could also have a scenario where cos is positive and sin is negative, okay? Now, you could have other scenarios, but I'm going to have to put that in a different area, maybe over here. So you could have a scenario where cos is negative and sin is positive, or where cos graph is negative and this one is also negative. Okay, now let's say they both were positive. Then if you had to multiply those two positives, you would get a positive over here. Here you have a positive and a negative, so that would be negative. Here you have a negative and a positive, which would be a negative. And here you have a negative and a negative, which is a positive. Okay, now they want to know, where is the product smaller than? That means smaller than 0, so that means negative. So we want this scenario, and we also want this scenario. So I'm going to scratch out all the others. Okay, and then I'm going to put this one down at the bottom here. So where cos is negative and sin is positive, because that gave us a negative. Okay, so what am I actually doing here? So let's start with this first one. They want to know, where is cos negative? Now, when they say negative, they mean under the x-axis. You know, if you have a graph that is above, that's where we say that it's being positive. When it's below the x-axis, that's where it's negative. So we want to know, where is the cos graph under the x-axis? Okay, so remember that the cos graph is graph f, which is this red one. So where is it negative? Well, it's here. Here's where it's under the x-axis. Okay. Now, at the same time, they want the graph of, they want the sin graph to be positive. So that graph is that's the G graph. So they want that one to be positive, so it must be above the x-axis. So that's over here, up to there. So where is the overlap? Well, the overlap is from here up to here. So we can say that, I'll show you set builder notation as well. You could say that x is an element going from 45, and we can include the 45 because they are also including, all the way up to 135. Okay. If you were doing set builder, you would say x is bigger than 45 and smaller than equal to 135. Okay, now we need to go and look at the second scenario where the cos graph is positive and the sin graph is negative. Okay, so we are going to see, where is the cos graph, which is graph F, the red one. Where is that positive? So that means above. So that's there and there, up to that point. And then we also need to see, where is the sin graph? Negative, which means below. Whoops. Which means below. So that is there. So where's the overlap? It's only that part. So now this is quite interesting. So you see how in this answer we went all the way up to 135, but now we can actually just let the answer carry on up to this ending position, which is at 180. So instead of saying x is an element from 45 to 135, we can say from 45 up to 180, and we can include that point. And then if you prefer set builder notation, you could say from 45 up to 180. Because we're going up to 135 for this first part, and then this answer goes from 135 anyways. So we might as well just say that it's all the way from 45, which is where the previous answer started, and just go all the way through to 180. The functions f and g are given. Determine the equation of h, which represents the graph of g shifting up by 1 unit and 30 degrees to the right. Okay, so g is currently sin of x plus 45. Now the graph of h is that graph shifted 1 unit up. Okay, so the way that you would modify that is by saying plus 1. Okay, and then 30 degrees to the right. Remember, when you go to the right, that means minus, and when you go to the left, that means plus. So we're going to then say h of x is equal to sin, and then you're going to say x plus 45 minus 30, because they said it's going to go 30 degrees to the right, and then plus 1. So that means x plus 15 plus 1, and so that would be the final answer. This question says, complete the line drawn from the center of a circle to the midpoint of a chord. Okay, so here's a chord. We're going to connect to the midpoint. So that means this side and this side are the same. So we should know that that means the chord is automatically perpendicular. So you're going to fill in the word perpendicular over there. Then this next one says the angle subtended by a chord at the center of a circle. Okay, let's draw what that means. So the angle subtended by a chord, so here's a chord, at the center of a circle, okay, there. So this angle here, which is at the center, is what? The angle subtended by the same chord at the circumference. So what they mean is, if you take the same ending points of this chord, and you subtend another angle on the circumference, which is the edge of the circle, then what is the relationship between these two angles? Well, you should understand that this angle here is double this angle over here. So we can say that the angle of the center of the circle is double the angle subtended at the circumference. In the sketch below, O is the center of the circle with OM perpendicular to AC. Okay, so OM is perpendicular to AC, so that this angle is 90 degrees. The radius of the circle is 5 centimeters. So that's 5 and that's 5, because that's the radius, right? From the center to the outside and from the center to the outside. First question, BC is 8 centimeters. There we go. First question, write down the size of angle BCA. So BCA. Well, we know that this line is called a diameter because it goes through the center. If you have a circle with a diameter, if you make any angle on the circumference of the circle, it'll always be 90 degrees. So we can say that angle BCA is 90 degrees, and the reason is called angles in semicircle. This question says, calculate the length of AM. Well, what we can do is we can use Pythagoras over here, which would help us to find this whole length, okay? So we can say that AC squared is going to be 10 squared, because that's 10, minus 8 squared, okay? And so AC squared would then be equal to 36, and so AC would be 6. Okay, so we know that this length is 6. Now, grade 11, the beginning of grade 11 circle geometry, we learn that if you have a circle, and you have a center, and you have a chord, and you have a line from the center perpendicular to the chord, then it means that this length is the same as this length, because it cuts it exactly in half. That then means that this length here would be 3. So we could say that, so we'd show all of that, and then you could say, therefore, AM is 3. And this is because you have a line coming from the center, and it is perpendicular to a chord. You see, we had a line that was coming from the center, was perpendicular to the chord, and so it cuts this line exactly in half. So the answer is 3. And we'd say centimeters, because they did use centimeters. Okay, so this question says the ratio, calculate the ratio of the area triangle AOM. Okay, so let's just quickly put a 3 here. So triangle AOM to triangle ABC. Okay. Okay, so this length over here is missing, and we need that because we need to know the base of that triangle. Or you might call it the height, the base, doesn't really matter. But we need this length, okay? So in this triangle here, we already know that this is 90 degrees. So we can do Pythagoras. So we can say 5 squared take away 3 squared, which would give us 16. And so therefore OM is going to be, or OM squared is 16, sorry. And then the square root of 16 is 4. So this length here is 4. So now we know that if you have a triangle, a 90-degree triangle, the formula for the area is half base times height. And the base and the height are always the two that make the 90 degrees. Okay, let's try that one. You can rather do those ones, okay? So, and so you could choose that as your base, for example, and that is your height. Or if you could choose that as your base and that is your height. It doesn't matter. You get the same answer at the end of the day, but it's always the two that make 90 degrees. So for triangle AOM, that'll be a half. Then your base and height. Well, here's the 90 degrees, so it's the 4 and the 3. It doesn't matter which one's the base, which one's the height. At the end of the day, you get 6 centimeters squared. Then for triangle ABC, which is the whole thing, see? Now remember, here's the 90, so your base and height would be those lengths there, okay? So it's going to be a half times, I'll choose this as my base, I said base, and then this could be the height, which would be this whole length here, which is 6. And so that's going to be a half of 1840 is 24 centimeters squared. So if we then look at the ratio of 6 to 24, that would simplify to 1 is to 4. So the answer would be 1 to 4. So with this question, I had to add something in because I tried this question a few minutes ago and it was impossible to solve without that information over there. On the memo, they wrote something that makes me think that they were using this, okay? But I think they forgot to put it in the original information because on the memo, they instantly said that F1 is equal to C1. Now, there is no reason that could be unless this EC is the same length as EF. Then we have an isosceles triangle over there. Okay, so I'm 100% sure about that. They must have updated the learners that wrote this exam on the day and told them to add something in. Okay, so in the sketch below, point O is the center, ABC or da-da-da, line AC intersects blah, blah, blah. And then I've added this in over here, that EC is the same as EF. Okay, I think that's what they would have told the learners, or they would have told the learners that these two angles are the same. Okay, one of those two things. Now, the first question says, prove that FC, so FC, is parallel to AB. Okay, so if we look, for example, at this chord, okay, BC. So let's put our fingers on B and C. Now, you see if your fingers slide towards F1, okay, where else could they slide? Well, of course, they could also slide there, but that means that this angle is double this angle, okay? But we don't need that right now. What if they rather went this way? They also come together up here. Okay, let me do that a little bit better. All right, so that is the angle, angles in the same segment, or it looks like a bow tie. Can you see it? It's not the best looking bow tie, but there is a bow tie there. And so from the bow tie or the angles in the same segment theorem, we can then say that this angle is the same as this angle. So that's where step 1 would be. So we'll say that angle BAC is the same as angle F1, and that is because of angles in same segment. Okay, the next thing, so let's just say that those two are the same. All right, and we're trying to prove that this line is parallel to this line. Okay, now here's where we can use the little Kevin add-in that I added in here, and on the memo they did the same thing, and I looked at the memo and I'm like, what, bro, like where did that even come from? They literally just said the following. They said that F1 is equal to C1. They didn't even give a reason for it. Like, I'll actually show you. Here's the memo. Now look at question 5.1 and then look at the second line there. So we did the angles in the same segment because I was really stuck with this question, guys. Like I couldn't solve it. You know I don't look at memos, but so I don't look at memos ever, but when I cannot solve it after like 5-10 minutes and it's a 2-mark question, well then I need to start looking at something. Maybe there's a mistake. And then they just say here, but F1 is the same as C1. Oh really, bro? Like why? Why would they be the same? It's only if that this would be an isosceles triangle or something. There's no other mathematical reason why these two angles are just the same for... They didn't even give a reason. They literally just say, but I swear, like in the original question, they might have even just said that F1 is the same as C1. I don't know. But we'll just take my add-in for now, okay? I don't really like this question. I think it's a bit off-putting that we've had to modify it. But so we know that these two angles that I've highlighted are the same so far. Now, we know that because this triangle is isosceles, or because EF and EC are the same, then it means that this angle and this angle are also the same, right? You know that's how isosceles triangles work. If you have a triangle where this side and this side are the same, then the two opposite angles are also the same. So we can now say that EF is equal to EC, and we'll just say given. Our home dog, Kevin, gave us that one. I think they gave it to the learners anyways. So the next thing we can say is, therefore, E1, angle E1 is the same as angle C1, and that's just because of they are the angles opposite equal sides. Okay? Angles opposite equal sides. Sometimes you might just want to say equal, doesn't really matter. Angles opposite equal sides. Okay, I see a lot of memos use this one, so I'll just stick with that. Now, okay, so we know that that's the same as that. So check this out, guys. Now, so what we've done is we originally said that this angle is the same as this angle, and then we've just said that this angle is the same as this angle. So that means that this angle and this angle must also be the same. So we can say, therefore, angle C1 must be the same as angle BAC. There's no reason, it's just because you see what we did? If these two are the same, and then these two are the same, well then that naturally means that those two are the same. And that means that these two lines are parallel, because have a look here. Ah, look at that, the alternating angles are equal. So we can then say, therefore, these two lines, AB and FC, must be parallel. Why? Because the alternating angles were equal. Okay, so this next question says, triangle ABE, prove that triangle ABE. Okay, so we know that those are now, I'm just going to quickly say that whole angle is X, that's X, and that's X. And we now know that these two lines are parallel. And so triangle ABE. So triangle A, B, and E. Okay, prove that is isosceles. Okay, well that's pretty straightforward, because if we just go like this now, we could say these two lines, we know that these two lines are parallel, so there's another alternating angle. So that means that this whole angle here is X. So we can say that angle F1 is equal to angle ABF, and that's just because of alternating angles, because the line AB is parallel to FC. Okay, so this whole angle here then is X. So then if we look at the triangle that they were talking about, ABE, we can then see that it's isosceles, because this angle and this angle are the same. So we can then say, therefore, triangle ABE is isosceles. Let's just say is isosceles. Why? Well, because the angle BAE is equal to ABE. Okay, because that angle and that angle is the same. Okay, guys, let's move on from this question. It wasn't the best. In the sketch below, O is the center of the circle. It is given that this is 76 and that is AX. Okay, so they've given us everything. It's for 5 marks. Calculate the value of X. Okay, so the first thing I think we can do is just to use co-interior angles here. So that means angle B would be 180 minus 76. Remember that co-interior angles are not equal, but they sum up to give you 180. And we could say here co-interior angles, because the line OC is parallel to AB. Okay, so then that means that angle B will be 104 degrees. So that is 104. So you know how when you get a circle and you have a line at an angle at the center, we know that that's always double the angle at the circumference. So this one, so for example, if this is X, then this one at the center is always double, right? So you see how it's always on the other side. So it's on the other side of this center part. It's never on the same side. It's always on the other side of the center, okay? But you also get extreme versions of that, where you've got a circle where it goes like this. So it goes up, and then you've got this. So then you can look at this angle on the outside once again, and that would still be double the angle that is on the inside. Okay? It's the same thing. Here it's on the outside, here it's on the outside, here it's on the inside, here it's on the inside. Okay? So this doesn't happen too often, but it's happening here. So that means that this angle is going to be double this angle. So we could say that angle O2 is going to be 2 times 104, and that is because of angle at center is equal to 2 times the angle at the circumference. Okay, so that means that angle O2 is going to be 208 degrees. So this whole angle is 208. So then we know that this is a revolution, so we could work out angle O1 as 360 minus 208, and that's just because of angles around a point. So we can say angles around point. And so if we're to work that out, that'll be 152. So this is 152. Now I think we can just use, I know we can just use parallel lines over here to find x, because they're co-interior. So we can say 180 minus 152, and that is because they are co-interior angles, once again because OC is parallel to AB, and so x would end up being 28 degrees. In the sketch below, point O is the center of the circle. Points P, Q, R, and S are concyclic. Oh, why did I have to use that word? Trying to be so fancy. So students get really confused when they see that word. It just means they're on the same circle. Goodness me, there they are. P, Q, R, S. Concyclic. Hello, darling. We're having a cup of tea. Come sit down while we do some mathematics and we look at concyclic circles. Seriously. Points T, O, and Q form a straight line such that point T lies on the line PS. Okay. Points T, form such. Okay. It is given that PQ is equal to QR. So PQ, that's important, is equal to QR. Okay. And Q1 is X, which they've given us there. So they haven't put in a Q1, but we can see that that's definitely Q1 because that's Q2. And there's the X. Okay. First question for only 7 marks. That was sarcasm. 7 marks. Woo, okay. Calculate P1 in terms of X. So we need to find this one over here. Okay, easy peasy. 7 marks is just overkill. Check this out. We know this triangle is a isosceles triangle. Why? Because this length is the same as this length. Why? Because those are radii. Okay, we shouldn't put 1 line, we should put 2 lines, because otherwise we're saying that it's the same as those. Okay, but now we have to go write all that down so we can try to earn our 7 marks. So we can start by saying that OQ is the same as OR, and that is because those are radii of the circle. So that means that angle R1 is then going to be equal to angle Q1. I know there isn't a 1 there, but they called it Q1, so we'll just do that. And that is because those, if you're an IEB student right now, you could say isosceles, but most of you watching are CAPS learners. So what we'll say is that it's angles opposite equal, well, we say equal sides. Okay, so that means that R1 is X. So this is X. So then we can work out this angle by just using sum of angles in a triangle. So O1 will then be 180 minus X minus X. That is because of sum of the angles in a triangle. So therefore angle O1 is 180 minus 2X. So O1 is 180 minus 2X. Now, you know the standard scenario where you have a circle and you have a center angle and then you have another angle like that. What do we know about the relationship between this one and this one? Well done. If you remember, and you're sitting there at home right now and you're like, Kevin, it's 2x. I mean, wait, where did the x come from? Sorry. You mean Kevin, it's double. Okay, this is just awkward. I've just ruined everything. Okay, let me just explain. So I was trying to like say something funny. Well, not funny, but just it was a moment. Okay, and I've ruined it. Okay, so we know that this angle here is going to be double this angle over here. So, for example, if this is x, then this is 2x. Okay, so, right. So, can you see it over here? We've got the same scenario opening up. We've got that. Sorry, we don't have to worry about that one. There we go. And then we've got that over there. You see it? So that means then that this angle here is going to be double this one. Okay. So what we can say is that P1 is just going to be half of angle O1. Because, I mean, you could say O1 is double P1, or you can just say P1 is half. It's the same thing, right? And then that's because of angle at center is going to be equal to 2 times the angle at the circumference. And so we could then say that P1 is going to be, so it's half of that, so it's 90 minus x. So we could say 90 minus x because it's half of the 180 and it's half of the 2x. So it's half of 90, so it's just going to be 90 minus x. Oh, and that's what they wanted us to find. I was like thinking, okay, wait, what do we have to do now? But P1 is what they wanted, so there's our 7 marks. I could sort of see how it's 7 marks. I mean, you get 1 mark there, you get 1 mark there, you get 1 mark there, you would get... Oh, and maybe you get a mark for the reason as well. And then here we said P1 is that, and then you get a mark for the reason. So 1, 2, 3, 4, 5, 6, 7. Okay, it makes sense. Cool. Okay, so let's move on now to this question over here. This question, prove that the line TQ, which is this one here, bisects the angle PQR. PQR is here. And they want us to prove that this line bisects this angle. So what they're actually wanting us to prove is that this is going to be the same as that. So can we prove that Q2 is the same as x? That is what we actually need to do, because then that means if this is x and this is x, then these two are the same, and so that means that this line is cutting this angle exactly in half, and that is what the word bisect means. So the goal is to find this as x. We want that to be equal to x. Okay, so remember in the very beginning they told us that in this triangle over here, this line and this line are the same. So that means that this angle and this whole angle need to be the same because they are the opposite sides of, so it's like an isosceles triangle, right? So that means that this whole angle, which I'll call PRQ, so we're going to say angle PRQ is going to be the same as angle P1, which is then equal to 90 minus x. And the reason is that angles opposite equal sides, because we know that these two are the same. They told us that earlier, okay? So that then means that this whole angle is 90 minus x. So we can say then that therefore angle R1 plus angle R2 is 90 minus x. So we now know that this whole angle is 90 minus x. So we can now work in this triangle, and we can then go work out angle, this big angle Q. So we can say PQR. So angle PQR is going to be 180 minus this angle. Now, because this angle is more than one term, put it in a bracket, please. And then this angle is also more than one term, so just put it in a bracket. Okay, and so that means we're going to end up with and the reason, sorry, is it's because of the sum of the angles in a triangle. And so angle PQR is going to be 180 minus 90 plus x minus 90 plus x. And so PQR is going to be the 180 cancels out the 90 and the 90, and so we just end up with 2x. Okay, so this whole angle is 2x. So we can say Q1, therefore Q1 plus Q2 is 2x. But we already know that Q1 is x. We know that from the beginning. So we can then say x plus Q2 is 2x. If you then solve for Q2, angle Q2, you end up with 2x minus x, which is x. And so look at that. We now know that these two are the same. And so we can summarize, this would be the last step. TQ bisects PQR.